Example 1 says to write the standard form of the equation and the general form of the equation of each circle with a radius r and the center hk. Graph each circle. So I have to write this in standard form and general form, and then graph. So this one tells me my r is 1, my hk is 0, 0. So if I am plugging in to this formula here, it tells me hk, this is my h, this is my k, this is my r. I mean, it says it right over here, but labeling it even a little bit more specifically. So I've got x minus h, my h is 0, plus y minus k, and my k is also 0, equals my radius, which is 1, and then squared. Now we can simplify this quite a bit. X minus 0 is the same as x, so this is x squared, plus y minus 0. Y minus 0 is y, so y squared, and 1 squared is 1. So this is my equation in standard form. So if you notice here, if your center is at the origin 0, 0, you won't have anything in parentheses here. That's just x squared, y squared. And for the record, this is your equation for the unit circle. And the unit circle is basically what trig is based off of. Okay, so you're going to be seeing this equation, or you're going to be using this circle specifically quite a bit in trig, which is considered the unit circle. You're going to find out that the graphs for this are all really awful. But to graph this, you would graph your center right here at 0, 0. And then if your radius is 1, you're going to go left, right, up, down, 1 in every direction. And then just make the best circle you can. All right, so I have this in standard form. Now I need general form. And in general form, you have everything on one side and it equals 0 on the other side. So all we're doing is taking this 1 and moving it over. So this is x squared plus y squared minus 1 equals 0. So let's try this one. This one's probably a better example. Worse graph, but better example. Okay. You have your R, you have your H, you have your K. So we'll start with standard form again. So you have x minus h. So we have x minus 4 squared plus y minus k. Minus k is a negative 3. So minus negative 3 is a plus 3 squared. And that equals your radius, which is 5 squared. Now, I can't simplify these at all, but I can simplify 5 squared. So my answer in standard form is x minus 4 quantity squared plus y plus 3 quantity squared equals 25. So for general form, we have to multiply these out and then rearrange. So x minus 4 quantity squared is x squared minus 8x plus 16. I've showed this before on previous videos. But x minus 4 quantity squared is x minus 4 times x minus 4. You have to FOIL, so that's x squared minus 4x minus 4x plus 16. Combine your like terms to get that negative 8x. Okay, do the same thing with these this y plus 3 quantity squared. Expand it out, FOIL. You're going to get y squared plus 6y plus 9. And that equals 25 still. And actually, instead of this equaling 25, let's just subtract that 25 over real quick. So then minus 25. Okay, so now just put it in the correct form. So you need your x squared first, your y squared, your ax, so that's my negative 8x, your by, which is 6y, and then combined your like terms. 16 plus 9 is 25, minus 25 is 0. And so this just equals 0. You've got no constant. But if it didn't zero out, then we would have plus or minus whatever. Okay, so that is my equation in general form. And you're gonna end up hating general form because it's useless and it's annoying and it gives us more work. Okay, so now let's graph on a really bad graph. You're going to start with the center at 4, -3. So we'll go 4, -3. Okay, that's the center of my circle. And then my radius is 5. So I'm going to go up 1, 2, 3, 4, 5. I'm going to go to the left 1, 2, 3, 4, 5. I'm going to go down as best as I can. 1, 2, 3, 4, 5. And then if we had room, and you have a little bit more room than I do since you have half sheets, but we would go over 1, 2, 3, 4, 5. And so then just make the best circle you can. So that is how to write your formulas for circles in standard and general form when you are given the radius and the center HK.